Alright, we're going to start section 8.3 by warming up with simplifying radicals. So remember, when it's just a regular radical, you make a factor tree, 25 and 3, and 5 and 5. Then once you get to that point, you circle your pairs. That pair is allowed to go outside the radical. The ones left uncircled stay inside. When you have a radical in the denominator, it's improper to leave it in the denominator. Kind of like in English, it's improper to not start with a capital letter. So we rationalize the denominator. And rationalizing the denominator is multiplying by what you see in the denominator. What happens is my numerator is now 10 square root of 2. And in the denominator, square root of 2 times square root of 2 is square root of 4. Well, now I still have a radical in the denominator, but the square root of 4 is a perfect square. That's 2. And 10 over 2 gets me 5. So we're able to get rid of a square root in the denominator when we multiply by that square root. And then 3 square root of 5 squared, think of it as 3 square root of 5 times 3 square root of 5. 3 times 3 is 9. Square root of 5 times square root of 5 is square root of 25. Well, that's really 9 times 5, or 45. Alright, so we have 3 different properties that we have to remember from simplifying radicals to be able to do most of what we're doing in 8.3. Today we're talking about a special triangle where the angles are 45, 45, and 90 degrees. So, let's start by drawing a square. Let's label that square ABCD. And I want to draw in diagonal AC. Okay? Triangle ABC. What type of triangle is it? Now, since I know it's a square, I know all 4 of these are the same. I know that all of these are right angles. I'm only going to label that one. It's got 2 sides that are the same and a right angle. It's an isosceles right triangle. So let's fill in the angle measures. If you're paying attention on the last slide, it's 45, 45, and this is already marked as a right angle. 45, 45, 90. Now the AB is 8. Find the diagonal. Well, if that's 8, BC is also 8. Let's call AC x. We could do Pythagorean theorem. 8 squared plus 8 squared equals x squared. Those are both 64, and so when I take 64 and I multiply it by 2, I got x squared equals 128. So x is the square root of 128. Now, you go through and you do a factor tree on the square root of 128, and what you end up getting is 8 square root of 2. Because into 128 there's factors that multiply to 8. So I have 8 square root of 2 when my sides were 8. So my question next is, what would the diagonal be if the sides were 12? When these are both 8, we got 8 square root of 2. So when the sides are all 12, we get 12 square root of 2. Here's a reference triangle. Our reference triangle, let's move it over, I'll write some stuff over here. If the side lengths are 1, we multiply it by square root of 2 to get to the hypotenuse. This reference triangle is also going to be used with a similar triangle proportion because every 45, 45, 90 triangle, if I draw another one right here, and I call this 3 and this 3, I know this one has to be 3 square root of 2. Regardless of what it is, we could even draw one using x, 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 and x square root of 2. We're going to use, I like to use a similar triangle proportion, 1 over the leg, because this is a leg, and regardless of which leg we're using, it's proportional. 1 over leg, because this one's also a leg, and square root of 2 over the hypotenuse. We're going to use this proportion throughout this entire section and even into the next couple sections. So let's find the missing sides. Since this side's 8, this one's 8, and we know that this one has to be square root of 2 times, times whatever the leg is. Now, when we go backwards, I multiply by square root of 2 to get to the hypotenuse. Over here I have to divide by square root of 2. So let's set up a proportion. I'm going to use this proportion. I only need 2 fractions because you can only cross multiply with 2. So 1 over leg equals square root of 2 over the hypotenuse, 9. When I cross multiply, 9 equals square root of 2 times x. So I'm going to divide both sides by the square root of 2. And let's just bring this all the way up here just so I have some room. X is 9 over the square root of 2. But as we saw in our warm-up, we can't leave it like that, so I have to multiply by that square root. 9 square root of 2 is in the numerator. In the denominator, square root of 2 times square root of 2 is square root of 4, or square root of 4 is just 2. So x is that, and y is that as well. So find the perimeter of a square if the diagonal is 10 centimeters. So let me draw in a square, and its diagonal. We know the diagonal of that square is 10. So 1 over leg equals square root of 2 over hypotenuse, which is 10. We don't need to write out hypotenuse. So cross multiply. 10 equals square root of 2x. Sorry, let me rewrite that. Square root of 2x. So x is 10 over the square root of 2. We can't leave a square root of 2 in the denominator. So because we can't have a square root of 2 in the denominator, we have to multiply by that square root. And this is actually the one we did in our warm-up. So 10 root 2 over square root of 2's times each other is 2. So we get 5 square root of 2. The question, though, asks for the perimeter. So this one's 5 square root of 2. This one's 5 square root of 2. And so are these as well. So all of them are 5 square root of 2. So 4 of them. So the perimeter is 5 plus 5 plus 5 plus 5. That's 20 square root of 2's. So our final answer is up in the top right. Now find the length of the hypotenuse of an isosceles right triangle if the length of the other two sides are 3 inches. So isosceles right triangle, we need to find the hypotenuse. These are both 3. I could do Pythagorean theorem, or I could do 1 over leg equals square root of 2 over hypotenuse. 1 over 3 equals square root of 2 over x. Cross multiply, x equals 3 square root of 2. Or I could just remember that to get from here to here, I multiply by square root of 2. So there's a couple different ways you can do that. Find the length of the other two sides of a right triangle if the length of the hypotenuse is 12. Now since it's an isosceles right triangle, because one of the angles is 45, that means the other one's 45 also, and this is 12, we could divide by square root of 2 to get to there, or Pythagorean theorem, because both of these are x, or we could do 1 over leg equals square root of 2 over hypotenuse, which is 12. When I cross multiply, I get x times the square root of 2 equals 12. So x equals 12 over square root of 2. And that's what I was saying here. If I divide by square root of 2, that's like doing this proportion, just maybe writing some steps. I think it's okay to write out this step because it helps you visualize what you're actually doing. We got to multiply by square root of 2's. So we get 12 square root of 2 over 2, because square root of 2 times square root of 2 is 2. These will simplify. Each one of those legs is 6 square root of 2. I never, ever want you to answer this as a decimal. If you type in 6 square root of 2 into your calculator, you're going to get 8.485, and it keeps going on forever. I never want that as an answer on a test or a quiz. Always answer it as something with a radical. And our last example, we like to see these types on an ACT. It gives you an isosceles trapezoid, meaning those are the same. And this angle is 45. So what we're going to do is we're actually going to break this apart into 3 shapes. Oops, don't know that. I want to also draw one over here. Now, both of those are isosceles right triangles. The reason they're isosceles right triangles, let me mark them correctly, sorry, double marks on both, is because that's a 45-degree angle, so is that, and those are also 45 up there. In the middle here, since this is 10, down here is 10, and if the entire thing is 24, that means there's 14 units remaining, and those are split equally, 7 and 7. The heights are both 7, because those are isosceles triangles. And to find these, we could do our proportion 1 over leg equals square root of 2 over hypotenuse, or we could multiply by square root of 2 and just get that this is 7 square root of 2 and this is 7 square root of 2. Now I need to find perimeter, so I take all the sides, add them together. 10 plus 24, that's 34, plus I want to add these two together. 7 plus 7 is 14 square root of 2. Those can't combine. You can't say 48 square root of 2. 34 is separate from 14 because 14 is multiplied by the square root of 42, or the square root of 2.